Sometimes mathematics allows things that seem completely impossible. For example, consider all natural numbers, 1, 2, 3, 4, 5. Now take only the even ones, 2, 4, 6, 8. It feels like there should be half as many, but in fact there are just as many. You can match each number with an even number, 1 to 2, 2 to 4, 3 to 6, and so on. So a part can be just as large as the whole. That's already strange, but it's only the beginning.
Now imagine you have a sphere, and you can split it into pieces, and then reassemble them into two identical spheres, without adding any material. This is called the Banach-Tarski Paradox, and it relies on the same idea. Infinity doesn't behave the way we expect.
So how is this possible? The key is that we're not working with the sphere as a solid object, but with all of its points, infinitely many points. Now consider a task. You have infinitely many boxes. Each one contains objects. You need to pick one from each box. With a few boxes, easy. With many, still doable. But infinitely many? You can't go through all of them. You can't complete the process. You can't even describe how to do it. And this is where the axiom of choice comes in. It states something very unusual. You can assume that such a selection has been made, even if there is no way to describe how. In other words, the result exists without an explicit process. That sounds like cheating, but it's a fundamental part of modern mathematics, and it allows the construction of very strange sets of points. So strange that they don't have a well-defined volume, don't look like pieces of an object, and can't exist in the physical world, but mathematically they are valid. And when you split a sphere into such pieces, you can rearrange them into two spheres, not because new material appeared, but because we are playing by the rules of infinity. In the real world, this is impossible, because matter isn't infinite, and objects can't be divided forever. But as a mathematical idea, it is completely correct. And it raises a deeper question. Maybe the problem isn't mathematics. Maybe the problem is our intuition. Because when it comes to infinity, our common sense simply breaks down.